So let's dive straight in with this one. Now, people often wonder, why do I need a spoil board when this is made out of MDF? Well, that is true. We can cut into this fairly easy, but if you start damaging and ruining this is the bed to the CNC machine. So ultimately, at some point, you would need to replace it. To try and replicate one of these is a bit of a pain. You've got all the holes for the insert, you've got the holes for the bolts, and the holes go the full length of the bed itself. So as I say, quite a bit of effort to replicate this. Whereas a scrap piece of MDF like this, it is much easier to replace when it gets damaged. So effectively, this becomes our spoil board, and we leave this as the bed to the CNC machine. So let's bring our bits in that we are going to be needing today. Now, the first obvious thing is a spare piece of MDF cut to a size of 400 by 400 millimeters. Now, today I am using 12 millimeter or ½ inch, but I will be providing you all of the files to do this in 6 millimeter, 9 millimeter, and 12 millimeter. So effectively 1/4 inch up to ½ inch. So you've got a bit of variation. As I say, all the files will be provided. So we need some basic tools such as a ruler, a square, and a pencil. Now, I've got a combination square here, but obviously you can just use a normal square as well, because we'll be doing some markings very shortly. We also need a couple of bits in order to machine the various parts. So we need a 1/8 end mill. This will be to machine the holes for where the inserts are. Then we'll be surfacing the spoil board later, which is taking a top layer of everything. So we'll need a surfacing bit. This is a 1 1/4 inch bit. This is a 3/4 inch bit. Now, you can use various sizes, and I will allow the files to accommodate for all the variations of sizes sort of within this range. Now, depending on whether you are using the router or the 400 watt spindle that came with the machine, you may need a different size collet to insert into them, as I say, depending on which one you are using. If you're using the 400 watt spindle, you will need a ER11 1/4 inch collet to go in there to take these bits. If it's the other way around and you are using the router, you will need a 1/4 inch to 1/8 bit insert in order to take the 1/8 end mill over here. I'll put links to all these parts down in the description area so you can access them. You will also need some tape and some CA glue or super glue in order to hold the board down. This is effectively what's going to fix the board down to the bed and hold it nice and secure. Towards the end of the video, we will move on to tramming, and I'll explain more about this jig a little bit later on. But the primary purpose, as I say, is to get this spoil board fitted, get all the holes machined, and then get it surfaced so it's perfectly flat. So let's move on and get that done now. So the first thing we need to do is create a reference point. Not only will this be the start position for all of our jobs, it will also be the corner position for the board itself, so we can guarantee it sits in the correct position. Now, what we're going to do is draw a mark 25 millimeters in from the left hand edge, and then also a mark 15 millimeters up from the bottom edge, like I have done here. If you do this with a square, you should be left with a nice corner, and that will obviously, as I say, be the starting point and reference point for the board. At the same time, you may as well draw a line 15 millimeters across the bottom like this. Just put a few dashes in place, and this will just help as a reference guide when we put the board in there later, because it will keep it nice and square with the bed itself. So now we have the reference point for the starting corner. Bring your MDF up and just line it into that corner, and then again along the line that you've just done at the front of the bed itself. That is close enough for me. Then just take a pencil and mark all the way around the board, especially the back edge. We'll need that as a reference point very shortly. Now, the reason we do that is so that we know where this is going to sit when we align it later, but we'll push it out the way now. And ultimately what we need to do, obviously, is stick this board down to the bed itself. So we're going to use some tape and CA glue to achieve this. I say CA glue, it can be super glue as well. It's pretty much all the same thing. We're going to put some strips of tape down from the front to the back, obviously to where we've just done that pencil line. And we're going to put them on the bed. Then we're going to do another set on the board as well. Effectively sandwich them together with some glue in between, obviously to hold it all down. So I'll work through that and show you how I do it now. So what I've just done, obviously, is laid the tape down. Make sure it is flat, that there are no creases in it. Now, typically, I would try and get tape as close to the edge as possible. We do have a fairly thin strip here, so it wouldn't really be holding much, but you can go the full extent. Get your tape right to the edges. You can even go in between if you want to fill all the gaps. Now, in terms of lining the tape up to the board up here, what we're going to do is drop this on top of it. Again, back in our reference point into the corner. Make sure it is lined up. Then we're just going to take the pencil and go mark, 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 and basically do this all the way on the front and back so you know where your tape needs to sit. We'll do that on the back end as well, flip it over, and then we'll put tape along those strips that we have just marked. So you can sort of see what's going on here. We're going to put some glue down on this, obviously drop the board on top of it, making sure it is in the correct position against our lines that we've already drawn. Put some weight on it, hold it down, make sure it is perfectly secure. Don't worry too much about the tape sticking out. We can always cut that off later with a sharp knife and clean it all up at the end. The glue's down, we're going to spray the activator on this side and then sandwich it all together. So within a few seconds, the board is stuck down and held extremely tight. Now, I do use the activator to speed that up. It does set the glue off, as I say, within a matter of seconds. If you want to give yourself a little bit more time, don't use the activator, just put the board down, get it in place and put a bit of weight on it, and the glue will eventually set after maybe 1 or 2 minutes. So the board is now secured. The next stage is to insert the 1/8 end mill and bring it over to this corner in getting ready to start the job. So because I'm using the router, I'm going to use a 1/8 converter, put the bit into that, and then I'm going to put this in place into the holder and secure this all in position. As a quick tip, always use 2 wrenches when tightening this up. So that's in and held secure. I'm now going to jog it over to this corner, make sure it is sitting dead on the corner of the material and touching just the top of the surface in order for us to get our 0 for the start position. So any eagle-eyed viewers may have noticed that I've just dropped the router down slightly in the holder. Now the reason for this is when I got to the edge, obviously I knew we had 12mm of travel that we needed to go through to cut this, but there wasn't 12mm of travel left before it had tripped the limit switches. So I've lowered this down slightly just to guarantee we can cut all the way through the material without tripping any of the switches. So what we can do now is load the job in for the holes, start this off and get them cut. So when it comes to loading the file in, it doesn't matter if it's Candle, UGS, Open Build Controller or any of the different control software. The steps are basically the same. With your bit touching the surface in that bottom left hand corner, the first thing you'll want to do with your machine connected is to click Reset 0 so it knows where we're starting the job from. We're then going to go up to the Open folder. Now I'm using the 12mm MDF, so I have the 12mm file in here already. But obviously when you download all of the files, select the relevant one for the material that you are cutting, whether it is 6, 9 or 12mm. So I'm going to select that and click Open, and it should now load in the file. We'll switch back to the visualizer so we can see what's going on. Obviously on here we have all of the holes that we need to cut out. So it's just going to work its way around this yellow path, cut all the holes out and return back to the beginning. So with all this done, all we then simply need to do is go to the play button and let this job run. Now normally when filming I try and leave it open so you can see what's going on with the router, but this is MDF. It is not a nice material to get in the air and start breathing in, so I have fitted the FoxAlien dust chute and connected it up to the FoxAlien vacuum. So what I'm simply going to do is run the job, let it cut the very first hole, just make sure everything aligns up, and then if that's okay I'm going to let it continue and do the rest of the job. So the hole didn't quite go all the way through, but there was only a skim of material left, so I punched something through it and I can see that it is in the correct position, so that is good. I'm just going to quickly readjust the file, make it just a fraction deeper, maybe 0.2 of a millimeter, and we'll continue running it. So all of the holes have cut and align with the threads underneath perfectly, so that is great. One thing I should have mentioned is that technically you can cut these holes using a 1/4 inch bit. Now the reason I do all my toolpaths using a 1/8 bit is to accommodate for the smaller powered spindles that some of you may be using. But with something like a Makita and a 1/4 inch bit, you cut these holes in no time at all. Now the next thing we need to do is surface the top of the spoil board. If you're not familiar with this process, even though everything looks level and flat, what you often find is the machine is usually leaning one way or another, and one corner is usually more proud than another. So what we're going to do is take a very thin layer off the entire bed itself, and it just guarantees that when the machine is then running later on, everything is perfectly flat and parallel with the machine itself. So we'll get set up for that now. First thing you want to do is take a pencil and literally scribble everywhere over the board. Now this may seem a really silly thing to do, and I'll explain what the purpose of it is. As I say, what we are about to do is skim the entire surface very lightly. So we're going to take something like 0.2 millimeters off all over. But if for any reason we still see pencil after doing the first pass, well, it basically means it hasn't taken it off somewhere. So we then need to run it again. So ultimately what we're aiming to do is skim the surface and get rid of all of the pencil all over the board. So although you can't see it, what I've simply done now is installed the surfacing bit into the router, returned it back to the start position, and obviously reset the Z so it's just touching the surface of the material. One thing I will point out, these surfacing bits are quite large. Obviously the bristles on their dust shoes will stick inside. So pay close attention. If they start to get tangled, stop your job immediately and take the bristles off, because you don't want it getting tangled and ultimately destroying your dust shoe. So what we're going to do now is load in the job for surfacing the material, which is basically going to go left and right and all the way across the board and take 0.2 millimeters off. Hopefully it should get rid of all of the pencil. If there is some pencil still remaining, we'll bring it back to the beginning, lower it down 0.2 millimeters, reset the Z position and go again until we get rid of all of the pencil. So that is the Spoilboard surfaced. All of the pencil has gone off in one run, which is excellent. As I said earlier, if you do have pencil remaining, return back to the start, lower it down 0.2 millimeters, reset the 0 and go again, and it should get rid of all the pencil marks. Now I should also point out, this is probably the best finish I have ever had on a Spoilboard. Whilst that is good, it is actually bad news for you as the viewers. Normally at this stage you are left with lines running across your Spoilboard. These are known as tram lines, and ultimately it's because something on your spindle is not perpendicular to the bed itself. So it is leaving these marks, and the next step is about correcting them. Now, although I don't have any tram marks, I will quickly run you through the process, so hopefully it will help you if you do have these marks. So this is a tramming jig. Its purpose is to magnify any discrepancies going on in terms of the spindle being perpendicular to the bed itself. Now this just fits into your collet. This is a cheap 3D printed one I designed. I will put links to the files in the description area below. But if you don't have one, don't worry. You can do the same thing with some Allen keys. If you take two Allen keys like this, zip tie them together, you basically get the same shape. That will go into your collet and you end up doing the same thing. Now I'll show you exactly how it works. As I say, its purpose is to magnify any discrepancies. I did think this Spoilboard had come out really well, but actually now I've fitted this, I can see that it is leaning one way. You may not be able to pick this up on the camera, but underneath there is probably about a millimeter gap, maybe just over. If I rotate this round, you'll hear it start to touch on this side of the bed. There we are, can you hear that? And the same if I go the other side. Now what this basically means is it's sort of touching this right hand semicircle going on here. So effectively it means that the spindle is leaning to the right hand side and lifting the left end up. Now to counteract this, effectively all I need to do really is slacken off the bolts holding the spindle and tilt this back the other way. And that is exactly what I'm going to do now in order to counteract this. So when it's left and right, as I say, slacken off the bolts in the carriage and you can twist it that way. When it's going front and back, you may need to do something else, like pack your Z axis out or consider adjusting the gantry itself using the bolts on the side of the plates. So but for now we can do this simple solution, slacken these off and, as I say, level this back up to try and get it in a better position. So what I simply did then was obviously adjust the angle of this. Now when I spin this round, you can see it's not touching on any side. So I need to lower the Z down slightly until it starts to touch again and keep spinning it round. So what we can hear now is it's touching on the back, but actually each side is pretty even. So what that means now is there is a slight tilt towards the back, so I just need to counteract that some way. As I say, maybe adjusting the bolts on the gantry just to try and level this up just a fraction. So to get to the bolts on that side, I literally had to stand in front of the camera, so you would have just seen my back. Basically, what I did, slacken the 4 bolts off on this side, slacken the 4 bolts off on that side, and it just allows enough play to adjust it. And when I say slacken off, I'm only talking quarter, half a turn, and you should just start to get enough movement in this to counteract it. Now, I just kept basically just spinning this around and adjusting that until it sounded even all the way around. Once I was in a position I was happy with, tighten the bolts back up and you should be good to go. But as you tighten them, continue to check it to make sure nothing moves. Now what we should hear is this sounding even all the way around. So that basically means our job is done, and we have trammed the spindle into as accurate well as I need it to be for this machine anyway. If for any reason you're finding adjusting the gantry isn't giving you enough, maybe consider packing the back of the Z assembly out either with some tin foil, some washers, anything just to adjust it. But obviously we've done it left to right and we've done it front to back. Not only have we fitted the spoil board, cut the holes, surfaced it, we have now trammed the spindle in, and you're going to get much better results as a result of doing all of this. So yeah, that is everything for this episode. Do hope you found it useful. If you did, as always, please give it a thumbs up and make sure you subscribe to the channel. Thank you very much for watching. Final thanks as always goes to my patrons, and I will see you all on the next episode.